Hi class, we're going to go over 7.2 while I'm away. I appreciate your understanding, and please feel free to rewatch this video as many times as you need to help you through the practice problems. 7.2 is about data displays and box and whisker plots. And so we started this in class, but we're going to go ahead and go over this again just in case anyone wasn't with us. The essential question is I want you to be thinking is how can data displays better help you understand data? So how can displays of data help you understand the data that you're looking at? Our goals are going to be to use the number line with dot plots and box and whisker plots to represent data, and then we're going to compare data using those displays. So let me highlight a few things in here. So up here in the essential question, data displays understand data, and then I want you to highlight number lines, because those are super important in this lesson, dot plots, and box and whisker plots. And then underneath here, I really want you to underline that word compare, because I want us to be using comparative words throughout this lesson. The first piece of vocabulary is this cutout that I provided you going over what a dot plot is. And so we're going to go ahead and highlight a few things in here. One of them being dot plot, of course. And then I really want you to underline the word number line, because a dot plot uses a number line to show how many dots, how many times a data point appears in a data set. So every single dot that you see in the dot plot here is itself one piece of data in your set of data. So in here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 dots. Therefore, in this data set, there were 20 pieces of data collected. The next piece of vocab goes over what a box and whisker plot is. A box and whisker plot, excuse my highlighter here, uses this thing called a 5-number summary. So those are our key terms. A box and whisker plot shows variability, which talks about how far things are spread out from one another in a data set. It gives us 5 pieces of data, or 5 very important measures. It gives us the minimum value, the first quartile, the median, the third quartile, and the maximum. And I want you to think, like, what does the word quartile make you think of? I hope the quart makes you think of a quarter. There are like 4 quarters in a dollar, or 4 quarters in a sporting game. So what a box and whisker plot does is it splits it into quarters. There's the first quarter, which goes over this whisker right here. That's a quarter 1. Quarter 2 goes from this rectangle to the median, to the halfway point. That would be quarter 2. And then quarter 3 would be from the median to the end of the rectangle here. And then the fourth quarter, the final quarter, would go from the rest of the whisker, from the edge of the rectangle to the end of the whisker you see. And so if you're given a picture here, if you're given a box and whisker plot, you can find where the data starts, where it ends, but then you can also find its halfway, or its markers. You can find the halfway point, and you can find where quarter 1 begins and where quarter 3 ends as well. And so let's just highlight this other word in here that's super important, which is the 5-number summary, and highlight a piece to pieces in here. So like the least values at the edge of the whisker. The first quartile is recognized by the start of the box. The median is recognized by the halfway line through the box, wherever that line is at. The third quartile is represented by this edge of the rectangle. And then the greatest value is recorded at the very end of our whisker. And you can see it gets its name as box and whisker plot because we have a box and then we have 2 whiskers that stem off from it. Another important thing that a box and whisker plot gives us is it gives us this new piece of terminology called the interquartile range. And I hope the word range stands out to you, because we've already talked about what range is. The range is the maximum minus the minimum value. So we're similarly going to be using that idea with range in here in general, but the interquartile should make you think like inner quarters. And so what we're going to do is we're going to subtract the third quarter minus the first quarter. And so we're finding the range of that rectangle, the box part of this. So I want you to highlight interquartile range is the range of the middle. And then I want you to highlight this part that says it's 50% of the data. We'll talk more about that when we get into our examples. And then our last thing I want you to highlight in here is that how you find it. The IQR is the quarter 3 minus quarter 1. Example 1 in 7.2, we are going to create a dot plot with a display, with some data that we're given here. So we're conducting a science experiment, and this science experiment is we're weighing mice. What is the weight of a mouse? You weigh some mice and you record the weight in grams, and then we want to display the data in a dot plot. So we're going to use a number line for sure if we're going to create a dot plot here. We're then going to use the data to determine the most frequent weight of the mice. Okay, so I'm going to go through here. Every dot plot that we have, we always need a number line. So here's my number line. I'm going to start with the smallest value. In this data set, we have 18 as the smallest value, and the largest value is 28. Okay, so I'm going to go 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I'm going to label every other one. That way it's easy to see all of our data. And I make one dot for every single data value up here. So I see 18 twice. I'm going to make 2 dots. I'm going to make 19 3 times because 19 is on here 3 times. And then we just keep going at this pace. And so I'm going to fill these out for us here. Okay, and so once you have finished your dot plot, you should definitely make sure and just take a second and recount. We had 5 in each column, so there should be 20 data values, so there should be 20 dots. 1, 2, plus 3 is 5, plus 6 is 11, plus 4 is 15, 16, 17, 18, 19, and 20. So we have 20 dots. Everything looks good. We just got to answer this last question, which is use the data that we see to determine the most frequent weight. Most should make you think of mode. I'd like you to underline that and write the word mode over here. Okay, which one is the mode? The one with the most dots. Therefore, the weight or the most frequent weight is 20, and then write grams because it was weighed in grams. Example 2, not example 1, I apologize, but we are interpreting a box and whisker plot in this example. We have 2 examples. We are determining the 5-number summary, so that is the big goal here. We're just trying to read a box and whisker plot given to us. So in part A, we have some body mass indices recorded of students in 9th grade. We have 5 things to find here, so I'm going to label them in different colors so it's easy to see. So we have the minimum value, we have the Q1, we have the median, we have the Q3 for the 3rd quartile, and last but not least, we have our maximum value. Okay, so how do we find the minimum value? That's right here at the edge. We find the minimum value at 17. That's where the whisker begins. So I'm going to say minimum value is 17. The Q1 is over here where the rectangle or where the box begins, and so our Q1 is 19. Our median is the halfway point. It's seen right inside of wherever the line is in the box, and so this one it's 21. Our Q3 would be at the edge of our box, so in this example it's 22. And then our maximum value is over here at the edge of our second whisker, which is at 28. Hopefully finding the 5-number summary from a box and whisker plot doesn't seem too intimidating just yet. So I hope you can see that it's super obvious to see all of the 5-number summary from a box and whisker plot. I hope you can try this one on your own. You can get ahead of me if you'd like. I'm going to try to find the minimum value. I'm going to try to find Q1 again. I'm going to find the median value as well. And then I'm also going to find Q3 and last but not least, the maximum value. All right, so the Q1 will be here at the edge of the whisker. That's at 120. We can see that the Q1 is at the start of the rectangle at 140. We can see the median would be at the center of the box at 180. We can see that the Q3 is at the edge of the rectangle at 220. And then last but not least, we can see the maximum value at 240. I definitely want to acknowledge here, you don't have to write any of this down, but listen carefully. 25% of the data lies within the first whisker. Another 25% of the data lies within the the second quartile, excuse me. Another 25% lies within the third quartile, and then 25% lies within each whisker. And so the reason why we call them quartiles is because 25% lies in each quarter, hence 25 per quart, right? So if 25% lies in this quarter, 25% lies in this quarter, 25% lies in this quarter, and then 25% of our data lies in this corner, it's easy to see where all of our data is, as well as easy to note where all of our whole data lies. Do we have any data values over here at 80? No, because 100% of our data is within this box and whisker plot that you guys see. As well as 50% of the data, which if you reference back to our IQR, the IQR is equal to 50% of our data. And that makes sense because when we look at the rectangle, that's two 25%. It's 25 plus 25, 50% of the data. Example 3, we're going to be drawing a box and whisker plot. We have the price of DVDs in a store. We have a list of all of those prices. It wants us to create a box and whisker plot, find the range, and IQR. I've gone ahead and highlighted what I needed you guys to highlight here for me. I would like you to also recognize that whenever you're trying to create a box and whisker plot, we need a 5-number summary. That way we can create the box and whisker plot without any issues. And in order to create a 5-number summary, we need to then put our numbers in order. Once you have your numbers in order, it becomes very easy to find the 5-number summary. We need the 5 components, which is the minimum, the Q1, the median, Q3, and the maximum. So we can find the minimum and the maximum fairly easy. The minimum is 12. We can find the maximum is 24. But the next one that's the crucial one to find is the halfway point. We have to start with finding the median after that and then find our quarters. You can't find the quarters until you found the median. So where's our median at? The median would be between 16 and 18 since we have an even number of data. So the halfway point would be this guy, which would be 17 between 16 and 18. And now that we've found our halfway point, we can now split our data into halves. We have the first half, which includes the 16. And then we have our second half, which goes from the 18 to the 24. And so the halfway point in our first half, which would be a quarter, would be between 13 and 15, which is 14. And then the halfway point between our second half, which is a quarter, would be between 18 and 20, which is 19. And now that we've got our data, we can create a number line and then plot our box and whisker plot. And so now that we've got our number line that I've created here, making sure that we started at our smallest number and going to our biggest number, very similar to how we did this with the dot plot. It's going to be a little different here. What we're going to do is we're going to put vertical lines for each of our 5-number summaries. So at 12, I'll put a vertical line. At Q1, I'll put a vertical line. At my median, I'll put a vertical line, and so on and so forth here. And so now that we've got our vertical lines, what we do is we're going to create the box. So our whiskers are going to stay the same. Our edge whiskers are going to stay the same over here. But what we're going to do is create a box from Q1 to Q3 by connecting those. And so what we can see is we can see our whiskers. The only problem is our whiskers haven't been connected. So we'll just connect them to our box here. And there's your box and whisker plot. Now what it does want us to do is also find the range in the IQR. So how do you find the range? The range is where we take the big number and we subtract the small number. So this would be like 24 minus 12, which gives us 12. And then the IQR isn't the big number minus a small number from the entire data set. Instead, the IQR is the big number in our rectangle minus the small number in our rectangle. And so it's asking for the range of just our box. And so our IQR would be 19 subtract 14, which is 5. I would like you to write this one in your notebook as well. I want you to try this on your own. And so I'm going to go ahead and solve this after you've tried it. After you put your numbers in order, which is always your first step when creating your box and whisker plot, because we need the 5-number summary. Looking for our 5-number summary, we see that the minimum is 18 at the very beginning, and we see our maximum is at 30 at the very, very end. We need to then find our median, and if you've counted your numbers, you'll know that we have 11 numbers. And so this one's a little different from the previous example. The 11 numbers means that we actually will have a perfect median, which in this example is 25. And we know it's the median because we've got 5 on the left and 5 on the right. And so now, after you've identified the median, the halves are a little different. So we take the numbers in front of them. So we do not include the median. So the first half would include 18 to 25, and the second half would include 27 to 30. So what would be our median, or our quarter one would be 24, 24. And then what would be our quarter three, which is also 30. It's the same thing as our maximum. And so if you're going to create a box and whisker plot here, it would look something like this. What you should realize here really quickly after you look at my graph that I've created is that we don't have an extra whisker. And that's because our maximum and our Q3, they're the same number. Yeah, so the end of our quarter is actually our maximum as well. We've created a number line to make sure we go from the smallest to the largest. And all we need to do next is just finish this off by finding our range. And I'm going to do this underneath the slide. So our range is taking the big number and subtracting the small number, which in this example is again 12. And our IQR is taking the edge of our rectangle, which is 30, and subtracting the Q1, which is 24. And so this one is 6.